Welcome to Across the Globe. Today we will learn about networking basics. Networking is the act of linking electronic devices to share resources and communicate. It facilitates the exchange of data among devices. Networks can be categorized as either wired or wireless. Wired networks utilize physical cables for connections, such as Ethernet cables in offices. Wireless networks, on the other hand, use radio waves for connectivity, like Wi-Fi in homes or public spaces. Overall, networking enables seamless communication and resource sharing among connected devices. Local Area Network, LAN, is a network that operates within a limited geographical area, typically within a single building or campus. It enables devices like computers and printers to communicate with each other. An example of a LAN is connecting computers within a school for sharing files and resources. In contrast, Wide Area Network, WAN, covers a larger area, spanning multiple cities, countries, or even continents. It allows the interconnection of LANs and extends connectivity over vast distances. One typical use of WAN is connecting branch offices of a company, enabling seamless communication and data sharing between different locations. In summary, LANs are suitable for localized networking needs within a confined area, while WANs are designed for extensive networking requirements across diverse geographical locations. Internet Protocol, IP, is responsible for identifying devices on a network and efficiently routing data packets between them. It ensures that data reaches its intended destination on the network. Transmission Control Protocol, TCP, ensures reliable, ordered, and error-checked delivery of data packets. TCP establishes a connection between sender and receiver, acknowledging data receipt to maintain accurate transmission. User Datagram Protocol, UDP, facilitates connectionless communication by transmitting data without establishing a connection first. UDP is suited for time-sensitive applications where some data loss is acceptable, such as streaming video or online gaming. For instance, in Python, using sockets to send data over TCP involves creating a socket, connecting to a server, e.g., w.google.com on port 80, sending data like an HTTP request, receiving a response, and closing the connection. This process exemplifies how TCP can be utilized for reliable data transmission in network communication. A router connects and forwards data between networks, while a switch forwards data between devices on the same network based on MAC addresses. A modem converts digital data into analog signals for transmission over telephone lines. In Python, a network switch can be simulated using dictionaries to route data packets based on MAC addresses. This is exemplified by creating a dictionary with MAC addresses as keys and corresponding IP addresses as values, then accessing the relevant IP address by specifying a MAC address key. Firewalls act as gatekeepers, controlling network traffic based on preset rules. Encryption secures data through encoding, allowing only authorized parties to decipher it. Virtual private networks, VPNs, establish secure internet connections to private networks. For instance, in Python, utilizing the cryptography module enables encryption like encrypting data using fernet from the cryptography.fernet module, ensuring privacy and security. Networking basics are like the roads and highways that connect different cities and towns. Just like how roads allow cars to travel from one place to another, networks allow data to be transmitted between computers. Routers act as traffic signals on the roads, directing data packets to their intended destination. Switches are like junctions that connect multiple roads, allowing data to flow smoothly between devices. Firewalls are like toll booths on the highways, filtering out unauthorized data traffic. Configuring network settings is akin to mapping out the most efficient routes for data to travel. Hey, code conquerors! Ready to level up? With TechLearn ATG, showcase your skills with official course certificates. Just visit our site and start. Need that extra boost? Get tailored learning, 24/7 support, and expert guidance. Coding smarter, growing faster, and making learning fun. Go to our website across the globe, www.atg.world. The network class serves as the central management entity for the network system. It contains a dictionary devices to store all the registered devices. The add device method allows adding new devices to the network by mapping the device name to the device object in the dictionary. When the send data method is called with a sender, receiver, and data, it checks if both sender and receiver devices are registered in the network. If they are present, it then invokes the find best route method to determine the optimal route for data transmission. If a route is found, a message is printed indicating the sending of data from the sender to the receiver via the identified route along with the data being transmitted. The find best route method implements a simplistic routing logic based on the type of devices. Sending from a PC to a server goes through router A, else it goes through switch B. The code also defines specific device classes like router, switch, and firewall, which inherit from the generic device class. This hierarchy allows for differentiating between various types of network devices and their respective functionalities within the network. In the if name equals main block, a sample network setup is created with devices like PC1, PC2, server, router A, switch B, and firewall C being added to the network. Finally, a data transmission is initiated from PC1 to server to demonstrate the routing functionality of the network. In a real-world scenario, this code could be extended to include more sophisticated routing algorithms, additional device types, and enhanced network functionalities to simulate and test complex network configurations and communications scenarios. One prominent example of networking basics in a real-world application is the Internet of Things, IoT technology. In an IoT ecosystem, various devices such as sensors, actuators, and controllers are interconnected to exchange data and enable automation. Networking protocols like MQTT, CoAP, or HTTP are commonly used to establish communication among IoT devices, enabling them to transmit data to centralized servers or other interconnected devices. Another practical example of networking basics can be found in cloud computing environments. Cloud infrastructure relies heavily on networking principles to ensure seamless connectivity and data transfer between servers, storage systems, and virtual machines. Technologies like virtual local area networks, VLANs, virtual private networks, VPNs, and software-defined networking, SDN, play a crucial role in optimizing network traffic and enhancing security within cloud-based architectures. Across the globe, keep learning, stay curious, and I'll catch you in the next video.